everyone, welcome back. In this particular video, we will be discussing the problem find the maximum profit by buying and selling stocks optimally. So a very large problem name, a very large problem statement also, but we will try to reduce the complexity of the problem. We are given an array in which the ith element is the price of a given stock on day I. It means we are given some prices of a given stock on some different days. We can assume it is given in an array. And given the array, which is having all the prices of given different days, what you have to do is you have to design an algorithm to find the maximum profit by buying a share on one day and selling it on another day. We have to sell a share and buy it, buy, sell, buy, sell. We have to do this procedure for some number of times to find out the maximum profit which we can figure out. You may repeat this process across the days. That is, you can buy one stock, sell it, and then again do it for multiple number of times. But a very important note is you may not engage in multiple transactions at the same time. Although we can do infinite transactions, as many transactions as we want, but multiple transactions can't be taken at the same time. It means you must sell the stock before buying again. So if I am saying you, if I am giving you an array, let's say, not array, but let's say I am saying you are buying a stock on some day, then what is the next possible thing which you can do? Can you sell it? Of course, we can sell a stock which we have bought. But can we buy another stock? No, this is not possible. We can't have two different stocks or a given stock with two different prices to be bought together. If we are buying a stock, we have to sell it. And then after selling it, we can again buy the stock on some other day and then again sell it. So this buy, sell can happen as many number of times as you want, but we can't just buy two times and then sell two times. This is not possible. So given that we are allowed to have infinite transactions, what is the maximum profit which we can make? Let's take the sample input. The number of days are given as 6, that is the array size is 6. The values of the prices of given days will be 7 at the first day, then 1, then 5, then 3, then 6, then 4. So if I draw a kind of chart, so first we have a price 7, then we have a price 1, then we have a price 5, then we have a price 3, then we have a price 6, and then we have a price 4. So these are the different prices of a given stock. And the question is, what is the maximum profit which we can make? See, if obviously I am going to buy a stock at 7 price, we can't sell it because first we have to buy it and then of course we can sell it. First buy should happen, then sell. If we are buying at 7, we can't sell it at a higher price. Obviously, profit will only be made if the stock is bought on a price which is lower than the selling price. But for 7, there is no selling price. What about 1? If we buy the stock at 1, can we sell it to a day on a day where the stock price is 5? Yes. So this is the first transaction which we are going to make. Buy at 1, sell at 5. Next, if we are buying at 5, obviously selling at 6 will give you 1 profit. Buy at 5, sell at 6, 1 profit will be there, 6 minus 5. But better will be to buy at 3. So that now if we will sell it at 6, the profit will be plus 3, not just plus 1. So here the profit was plus 4, here the profit was plus 3. And of course, if we are going to buy it at 6, we can't sell it because after 6, there is no profit day. So the total amount of profit which you can make it is the first transaction having profit 4, second transaction having profit 3. Total profit will be 4 plus 3, which is 7. And that is also given in the explanation. Buy on the day 2, then sell on the day 3. Then buy on the day 4, then sell on the day 5. And total profit will be 5 minus 1, 4, plus 6 minus 3, which is 3. Total profit will be 3 plus 4, which is 7. So given this kind of array, we have to find the maximum profit. Let's take another test case, which I have already drawn actually. This is a bigger array having almost, you can say, 13 days. And on each day, some price is given, like 1 on day 1, 3 on day 2, 2 on day 3, and so on. And we have to figure out what is the maximum profit which we can figure out. The point is, Either we can explore all the choices possible, that is try to buy on this day, then sell on other day, then buy on this day, sell on another day, and so on. But this will actually take a lot of time because we have to ensure that we are not buying a stock twice. So better will be just go in a systematic manner, just go in a sequential manner. That is, try to figure out if I am buying a stock at the current day, or if I am selling a stock at the current day, should I buy it on the previous day or not? As simple as that. Why? Because if I am just comparing adjacents, if I am climbing up the hill, that is, if I am buying on a smaller day, on a day with a smaller price, and selling it on a next day with higher price, I am going to make profit. And why not I should take the global peak? Why not I should say that directly buy on day one, and let's say in this example sell on day 5? Why should not do a single transaction d1 comma d5? Why we should do all these 3 transactions, first d1 to d2, then d3 to d4, and then d5 to d4 to d5? The reason is, if we will just do a single transaction between day 1 and day 5, the profit which you will make will be 7 minus 1, which will be nothing but 6 only. But what about these 3 blue transactions? If we talk about these 3 transactions, it will be 3 minus 1, 2 profit, 4 minus 2, again 2 profit, 7 minus 4, we can say 3 profit. Total profit will be 2 plus 2 plus 3, which is, we can say 4 plus 3, 7. So 7 profit versus 6 profit. Obviously 7 profit is better. Same here for the second hill. Instead of directly just buying on 9 and then selling at 11 or 12, the profit will be the day 12 having price 7 minus day 9 having price 0. So 12 minus, actually 7 minus 0 will be 7 only. Instead of having just a single transaction, better will be to do 2 transactions. First transaction, day 9 comma day 10, that is 4 comma 0. So 4 minus 0, 4 profit. Then this transaction having 7 minus 3, which is nothing but 3 profit. Total profit will be again be 4 plus 3. Actually, have we done something wrong? This is 7 and this is 3. So 7 minus 3, 7 minus 3, not 4. 7 minus 3 is 4. 4 plus 4 will be 8. So total profit will be 8 more than 7. That is, having just immediate transactions, just immediate days. We are buying on day 1, selling on day 2, buying on day 3, selling on day 4, buying on day 4, selling on day 5, will be better than waiting for a bigger price a day. Why? Because we are now capitalizing over these downhills. That is, if we are taking this 2, we are again taking this 2, and the portion is common. The height 1 is common in these 2 things. So we are again able to take the hike. We are again able to take the profit by doing multiple transactions instead of just doing single transaction. And should we take the transaction between d5, d6 also, between d6, d7 also, between d7, d8? No. If we are having a price drop, or if we are having a same price, we should not take it. From going to d7 to d8, the price will remain same. So 2 minus 2 will be 0 only, no profit. If we are going to take a transaction by buying on day 6, selling on day 7, it will be actually 2 minus 6, minus 4 profit, or you can say 4 loss. Why we should take loss? We should not take loss. So we will only take those transactions where the current day price is more than the previous day price. Day 5 was having price more than day 4, day 4 more than day 3, day 2 more than day 1. We should not take transaction between day 2 and day 3. So adjacents can be compared, and if we are getting a hike, we will add it in the total profit and we will just return that total profit. So in this case, what will be the total profit? 3 minus 1, 2, plus this profit 4 minus 2, 2 again, plus this wala profit is 3. Next, these are negative, so don't take them. These are negatives or 0, don't take them, but take this profit 4, take this profit 4, and finally last profit is negative, so don't take it. So total profit we can say will be 7 plus 8, which is nothing but 15. 15 will be the total profit, if I am not wrong in the calculations. But logic is pretty simple. Let's just do what? Let's go to the portal and write the instruction manual. What we're going to do, we're going to set a variable which is total profit. Set a integer variable profit initially to 0, because initially profit will be 0. Now compare the adjacents by comparing I with I plus 1. So run a for loop over indices I from 0 till last index, till prices dot length, till the last index, till last index. But what we have to do, if we are comparing I with I plus 1, both I as well as I plus 1 should exist. And when the I will be the last index, in this case, when it will be day 13, next day does not exist. So in such a case, if you will just run the loop till last index and you will get I plus 1, it will give you index out of bound error or exception something. So just make sure you are not running the loop till the n minus 1th index. You are only running the loop till n minus 2th index. So I will run from 0 to n minus 2, where I am just writing where n is equal to the array length, the prices array's length, prices array length. Every time what we have to do, we have to check if the current day price is less than the next day price, or you can say next day price is more than the current day price. So if prices at I plus 1 day is more than price at ith day, what we have to do, if the price at the next day is more, just take the profit. So we will say add the difference in prices at I plus 1 and price at I in the profit variable. Just add the difference, that is add 3 minus 1, add 4 minus 2, and so on. Add the difference between the prices in the profit variable. And when the entire for loop is done, we can just return the profit variable. That is the maximum profit which we can make, given that we are allowed infinite transactions, such that no two transactions should take place simultaneously. Multiple transactions should be taken, but at one time only one transaction should be there. So this will be the pseudocode. What will be the time and space complexity? As you can see that we have to run a loop over the input array. A single loop will be there, just running a loop over all the days. It will be order of n time complexity, where n is the number of days, that is the array size. And space complexity, since we do not require any extra space, space complexity will be constant. We are just having a variable profit, and that will be 4 bytes usually. We will be writing the code for the problem. So we are creating a profit variable initially, which is set to 0. I am writing the code in Java programming language for now. We have to run a for loop starting from index 0. We have to start the loop from index 0 and go till the second last index. That is, index will run till less than prices dot length minus 1. That is till less than equal to n minus 2. And index plus plus. Every time what we need to do, we need to check if the current day price is smaller than next day price, or next day price is greater than current day price. So if prices of I plus 1 is more than, greater than prices of I, it means we are going to uphill. Uphill means we have to take the profit. So how we can take the profit? We can just add the current transaction, that is prices of I plus 1 minus prices of I plus 1 minus prices of I in the total profit variable. And finally, we can return profit. The code is pretty simple, but for now, just to show you all the transactions which we are doing, let's just print the transactions. So I am printing the transactions by printing the buy day and then the selling day. So I am having an arrow where I am saying, first I am writing the buy day, that is the buy price on ith day, and the selling price on the I plus 1th day. Let's check the array which we have taken in the sample video, where we were having actually 13 days, and all the days, let's just write the values. So it was 1 3 2 4 7, 1 3 2 4 7, 1 3 2 4 7. Let's just, after having 7, have 6, then there is 2, then again 2. So 6 2 2, then finally 0, 6 2 2 0. And then let's do it for the remaining days, that is having price 4 3 7 6, 4 3 7 6. So let's write 4 3 7 6. So hopefully the input I am giving is the same input which we have done the dry run on. Let's see if it is going to give me 15 output or not. If the dry run which we were doing was correct, if the calculations were correct, it should give me 15 output. But there is some problem, most probably with the code itself. It is going in index out of bound somewhere, or some other issue. There is a profit variable initially. We are running a loop over all the indices. starting from 0, going till prices dot length minus 2, that is less than prices dot length minus 1. And if next index price is more than the current index price, what we are checking? We are saying that just add the difference of the prices in the profit variable. And once it is done, we are also printing it. And finally, we are returning the profit. Let's run it again to see if it is now running or not. Like, we have not done any changes, but it might be a platform issue or a portal issue somewhere. Maybe let's remove this input. There might be some problem in the input itself. Let's run it without giving a sample input. So we can say that there is a variable prices which it cannot find, or actually if condition it cannot find. So there is some problem with the curly brackets. If we are having this curly bracket, the variable I is not declared. Okay, so variable I is not declared, so we can run the loop over index instead of idx, having, let's say, I only. If I will run it again, let's see if it is working fine or not. For the sample test case which they were giving me, it should give me 7 for the test case which they have provided, and it is actually like taking for a different test case. At the output it is giving me is 4, and all the transactions it is also getting printed. But let's just take the sample test case which we had done a dry run on, that is having 13 days, the bar chart which we drawn. So it is taking some time to run. Hopefully it should give me all the transactions. As you can see, the output is 15. That is the total final profit is same. Transactions are from 1 to 3, 2 to 4, 4 to 7, then from 0 to 4, and then 3 to 7. So all the transactions are same as discussed. Let's just remove this print line, which we have done for the debugging, although there was no error in the code. But if I will run it now, it should give me accepted for the sample test case. And let's wait for it. And if I will submit it, it will work for hopefully all the test cases. Let's see. It is taking some time to run. And as you can see, all the test cases, corner cases are getting passed. What is the time complexity? As you can see, there is a loop running on the array of n size. The total time complexity will be linear. And the space complexity, since we are not taking any extra space, we are not creating any array or any other data structure, space complexity will be constant. That is order of 1. So with that, we are done with the problem. Find the maximum profit by buying and selling stocks optimally.